So now we want to extend the power of this base class. Because so far we've just essentially used classes in the way we use a struct. So what's the big deal with this inheritance business? That's what we're about to find out right now. So let's say we want to create a few more shapes, okay? And get specific with them. Instead of the generic shape, we want to be able to say rectangle, square, and circle. Okay, and have all the functionality that we have for shape in these three classes as well. Now, one solution is to simply cut and paste the internals of shape into these three other respective classes, right? And that'll work. We would have to change a few things, but for the most part, that idea of cutting and pasting, putting in there, that works. But there's problems with that. With maintenance, you have the same code being repeated. If you change one, you have to change the rest, etc., etc. And as the number of classes gets bigger, you're going to have to do a lot more cutting and pasting. Instead, there's a much more elegant way, and that's using subclassing. So let's just look at rectangle for a sec. And let's look at the functions we've defined and we want all our shapes to have. So we want it to be able to return an area, and we want to be able to return the bounding coordinates, okay, as a tuple. Well, rectangle essentially does nothing. There's no more functionality that's really needed other than what's in the shape class. Okay, so if we inherit from that, this is how we do that, with a colon and then just the name of the parent class. Instantly, this rectangle class now has all of the methods and all the properties that the parent class has. And in this very lucky case, we're basically done. Rectangle will behave as we expect because the bounding width and height is identical to the actual width and height for a rectangle. Okay, so the calculate area will return the correct value. Get bounding coordinates would be the same. So we're in good shape. And to test this out, let's just declare a variable of type rectangle. And you can see Xcode already recognizes an initializer that mimics the parent's initializer. So it does that for you. We'll make it 10 by 10, and voila. It seems to work just fine. And again, we can calculate the area for the rectangle, and it does what we expect. Okay? So far, so good. Let's move it up a notch. So what about square? Well, square is essentially the same as a rectangle, except the width and height are equal, right? So for the square, you might think that we all need to do is subclass from shape and we're done. Yes, this will work. The area will return the correct value. But we can be a little bit more clever. What if we could help the programmers that use our library of classes by enforcing this rule that every square that's made has to have the same width and height? Okay, how would we do that? Well, the answer is we can enforce this invariant by declaring the right initializer. Okay, and so since every class has to go through some initializer to create an instance, if we just pick one that's defined a certain way, we know that all construction paths have to go through this one initializer. And so in this one initializer, we just want to enforce this width and height are the same by having that be our sole argument to the initializer. So instead of separate width and height parameters, we just have one that stands for both the width and the height. Okay? And so once that initializer is called, then we can reuse the parent's initializer by calling super. All you do is say super dot and then init, and then this will jump up to whatever init functions are available up in the parent class. Okay, in this case, shape. So when we did that, Notice bounding width, bounding height again are there. So in this case, we just want it to be the same. And we are done. So very elegant, very beautiful. And again, just a few lines of code, and we can enforce this invariant in a very elegant way. So I'm going to have you go ahead and, as an exercise, play around with that class if you don't trust it just yet. But it basically works as you'd expect. Now, what if we wanted to build a circle class? So for the circle class, it's also kind of shape. But what's different this time? Well, the biggest difference is that the area function that we use in shape is not going to work for circle. And that's because the bounding box for a circle is different than the circle itself. So that means we need to add a little bit more code. So the first thing I'm going to do is have an additional property, we call it radius. We don't strictly have to store this radius because the bounding width is going to be equal to the radius times 2. But just for clarity, I'm going to go ahead and do that, and also to demonstrate how you store properties in subclasses. It's the same way as before. And then you want to have an initializer that takes this radius. All right, so that radius is getting set. And then once that radius is set, then we can call the super init function. Here the bounding width is going to be radius times 2, bounding height, radius times 2. Okay? And just so you know, the full extent of how initializer and chains of initializers work in sequence is a deeper topic. But just know for now, the basic rule of thumb is you have to do whatever property initialization in your class first before you can call superinit, before you can pass up to your subclass or up to your parent class. So if you had a bunch of properties, you'd have to initialize all of them first here, and then you can call superinit to set the remaining ones. Okay. So now we get to the area function. So for the area function, we're going to need another keyword, and this is override. This tells Swift that we're about to override a class method. And what that means is that we're going to take an existing class method signature from our parent, but then provide a new implementation of that method. So the signature is the same as before, but now in the code, let's do something like this. Where we do pi r squared, right? And then we return area. I'm being very verbose here. You can be more compact in your programming, but I'm just trying to be very clear for the sake of learning. And so now what do we have here? We have a circle that has its own custom accurate calculate area function and its own member called radius, but it's reusing all the code of its parent, except for the calculate area function, which we've overridden. Okay. And so this is yet another example of how subclassing, the power involved in it and the elegance involved in it. For relatively little code, we get a brand new class that shares some of the functionality of the parent. There's also some other benefits too to subclassing. Not only do you reuse the code, but Swift knows that they belong together in a hierarchy. And that means if you want to be able to convert types from one to the other, from a subclass to its parent, parent to a subclass, Swift will allow for that. This may seem unnecessary at this point, but we'll see some good examples of how this is very, very powerful. So first off, though, let's just create a circle, make sure this works. Sure enough, And so now if we print out the area, does it print 16? No, it prints 50.26 something, which I trust is actually pi r squared. And if you kind of estimate it, pi is 3, 16, that should be 48. It's a little bit more than that. That looks right to me. I'm convinced. So the area function is doing what we want, is calling this calculate area, not this calculate area. And why? Because we provided an override function in the subclass.